All right. Well, happy Wednesday, and just adjust the volume here. Good morning, and thanks for showing up. The six of you, I appreciate that. Okay. Well, let's take a look at. Well, actually, before we get into today's lecture, let me just talk a little bit about the midterm exam. So the midterm exam is 1 week from today, so it'll be Wednesday at this time. So just come here. Those of you who are watching, be sure you come to class. You will be allowed to have a note sheet. These are the exams, the rules regarding the note sheet. So you are allowed one sheet of paper, writing on the front and back. It can be handwritten, it can be typed. If you want to, I've seen people like take, I don't know, I guess screenshots of my lecture notes and shrink them down, and they like tiled their paper. Like, that's allowed, okay? So no real restriction on what you put on the note sheet. The one rule I have is you have to make it yourself, okay? You can't just have your friends make a note sheet and you say, hey, give me a copy of your note sheet. That's the one thing I won't allow. Make sure you put your name on it. I will ask you to submit your note sheet with the exam. So if you want to keep your note sheet because you're proud of it, you can make a copy for yourself to keep later. But I will ask students to submit their note sheet with the exam. I will provide this regular expression cheat sheet. You can see it yourself what that looks like. So this will be included with the exam. So you don't have to put any of this stuff onto your note sheet. There's most of this stuff we covered. There might be a couple things in here that, some of this assertion stuff, some of that stuff we didn't cover, and a couple, like global match. But a lot of these things we did cover in our regular expression lecture. Yes, question.
Do we have to print out the one you just showed?
No, that will be printed out with the exam. So when I pass out the exam, it'll be one of the pages in there. Okay. Also, I am including. This is an old exam, and so you can kind of look at this to get an idea. Last year I made my exam too hard. It was not intentional, but the average score ended up lower than I expected, and so I had to kind of make an adjustment. But pretty much these are the lectures that will be covered. I've listed them off here, lectures 1, 2, and things like that. There's and it tells you these things will not be covered on the exam. So most of the exam will be something like where I show you some code, probably some poorly written code, I'll say, and I'm going to ask you, what is this code going to do? Because the thing is, as you write code, if you write good code, there's no problem. Okay, the problem comes down to how well can you troubleshoot issues, right? And sometimes that arises because you wrote some bad code. You didn't follow good practices or things like that. So your function might be referring to values that exist outside of the function. Your function might have funny names or things like that. And so can you kind of follow along, some code that exists? And so I'm going to say, hey, if this is the code that is written, what is the output that this code would produce? All right. And to kind of check yourself, you can always just type in what you see here into R and then see what it executes. And you can see if your guess matches what R is going to output. Okay. So that's that. I will send out a seating chart. Okay, so it's a little bit you know, it's like, what are we in, like junior high or something? But I will send out kind of a seating chart that will just say, hey, I want you to sit over here and I want you to sit over there. It's I know it feels a little bit strange, but it's helped manage some kind of issues that have arisen in the past. So you can expect something like that to come out probably Tuesday, the day before the exam, with telling you like where to sit. Okay. Any questions before I dive into today's content? Okay. You guys can see this stuff, right? It's available. Okay. All right. Yeah, that's going to be Valentine's Day. So, all right. Today we'll look at more object-oriented programming. We're going to look at the R6 system, and we'll take a look. Okay. So, I guess I want to say one more thing. On Monday we looked at S3, and we got through. There were slides towards the end of the last few slides were the self-quiz, and I produced a little video that kind of covers the self-quiz, goes over the answers there. So that's there. I think a good number of you have watched that video, so that's great. Okay, let's see. So the R6 object-oriented system uses encapsulated OOP, and this is different from generic function OOP. So S3 uses generic function where the methods belong to the verbs. So you have something like shoot, and depending on the object I give you, that word shoot will take on different meanings. Okay, this time we give you the object, and the object says this is what I'm capable of doing. This is a camera, and the camera is able to do something like shoot a picture. The camera is able to record a video. The camera is able to format memory card or something like that. Okay, these are the actions, the methods that the camera object is able to do, and so that's how R6 works. Probably familiar to those of you who've done object-oriented programming in another language. Something like Python uses encapsulated OOP. Those methods belong there. Okay. R6 objects are what we call mutable, meaning they can be modified in place, and they also have reference semantics. So one thing about R6 is that it has to be loaded in with a library. So you might have to do install.packages R6. I've seen some questions on CampusWire regarding like, why are my packages not working? And so I do want to just point out that in RStudio, there is the packages pane over here. Okay, there's an update available. All right, so I'll have to update that. Oh no, I clicked the wrong button. Okay, I don't want to do that right now. But I will update my RStudio in a moment. Okay, I'm going to do remind later. Okay, so over here in the lower right-hand corner, on my screen at least, so you have like the help and whatnot, there is the packages pane here, and you can do you can click install, and you can choose something like R6 here, and you can say, here's the R6 package. And then sometimes if the repository doesn't work, you can actually download the original thing. But generally, the repository is fine. You can also try to kind of set which repository you want to download from. But anyway, this is how you can install packages. You can also just do install.packages, and then you can also take the packages that do exist, and you can click update, right? So you can take one of these things, and you can click update. Or I guess these are all the packages that have updates and stuff. I'll have to do that in a moment. But anyway, you have that. You can also kind of you can load libraries. Dplyr. I can just kind of click here, and that's gonna load up the dplyr and things like that. So packages pane is handy. Anyway, we're going to load up R6 here. R6, and we'll do that. Encapsulated classes with reference semantics. That's what we want. Okay. All right. So this is what we'll do. Basically, you will create a new class, a new object class using this one function, R6 class. That's pretty much the only function in the R6 package that you will need to use. And when you use this function, you'll have to provide two arguments. That is the name of the class and basically a list of methods or fields that belong to the object. The name of the class, by convention, we use upper camel case. Upper camel case just means you have two different. If you have multiple words, you write the first letter of each word in capital, and then the rest of the letters in lowercase, and you have that. And the first letter is a capital letter, and so that's upper camel case. If the first letter was lowercase, that would be lowercase, lower camel case. And then the public methods and fields are snake case, meaning you separate words with underscores, and that's whatever, snake case. Okay. Always assign the result of an R6 class into a variable that has the same name as the class, and this is going to become basically your creator function. So here I am going to use the R6 class function, and this is going to create a new object that is an R6 class object. We are going to give it the class name accumulator. So this is just the name of the class, and you'll notice I am assigning the result of that back into an object called accumulator. So you want to have this thing match this thing, just so things don't get too confusing. Again, it's not going to throw an error if you don't follow this, but to kind of keep things straight, it's best to have the same name. Much like when you use method, you want the function name to match kind of the argument that goes inside use method. But anyway, so we've got accumulator. We have accumulator here, and then the second argument is public. And inside public, I have a list, and this list has two things in it. It has a field called sum, and right now sum just takes on the numeric value 0, and it has a method, and this is a function called add. So within the list, I've got two things. I've got sum, I have add, and we'll break down what this function inside this method called add is doing. But that's what we have. So just kind of want you to pay attention. R6 class, there's two arguments coming in, class name and public. Public itself is a list, and list has two things in it, a field called sum and a method called add. And so when you do that and you say, hey, what is accumulator? So remember, we assigned the result of R6 class to accumulator. This says accumulator is an object generator for class accumulator. Accumulator class object generator. These are the methods, or these are the public things. We have sum and add, which is a function, a method. And we see, there's also a method called clone. And this is going to be something that all R6 class objects, a method that all R6 class objects inherit. It says the parent environment is the global environment, and there's some other information there. Okay. So now that we have this accumulator class generator, okay, which is what we call accumulator, we can create new instances of the accumulator class object, right? So you have to think of this kind of like in some cartoon. You have the machine that, like this machine that will say, I'm going to produce robots or something, right? And you push the button, and then it pops out a thing. Okay, so here we have the accumulator generating machine, and now I push the button, basically accumulator $new, and out pops this object X. Object X is an accumulator class object, right? And if I push the button again, it's going to produce another accumulator class object here, right? So just, in the cartoon, I feel like this is a common thing that happens in cartoons. Somebody creates the machine, and then the characters, they just keep hitting the button, and it keeps producing all of these little robots or something like that. And that's basically what we have here. So this is the object generator, and then every time we call $new, it's going to create a new instance of that object. So X itself is an accumulator object, and it has the function add, the method add, and it has the value 0. And so if we can say, hey, X is this object, what is the value of sum in X? We get the value 0. Okay, and then I can call the function add. So what add will do, the function here says, hey, what we're going to do is we're going to just take the current value of the sum, which is 0. We're going to add X to it and update the value of sum, and we're going to kind of return itself invisibly. We'll break that down. So we can say, hey, take X and add, and it's going to add 1 to it, and we can say, hey, what is the sum of X? And now it's 1. I can say add 3, and I say, what's the sum of X? And it is now 4. So what is that thing doing? Okay, when we call add, we're calling this method here, which is a function, and it's saying, look within itself. Okay, so within a method for an R6 class, you can say, hey, look at the values that you have inside yourself, and inside ourself, inside the accumulator class object that we've created inside, we have a value called sum, right? So we're going to say self.sum, and then you have a function. So here we say this function takes in an argument x. We're going to do self$sum plus x. Okay, and we're going to store that back into self$sum. And what this invisible self does is this method returns itself. Okay, it returns itself invisibly, which means the value or the object is returned. The self is returned, meaning you can kind of store that thing somewhere, but it doesn't print anything out to the screen. Okay, and by returning itself invisibly, it allows you to kind of chain methods together. And so, for example, if I say, hey, what is $sum? X is that one instance of the accumulator, and currently its sum value is 4, and I can do $add 10. And so now what that is going to do is this itself is the object. It's returning itself, but the sum is now 14. And because it's returning itself, I can also chain another method. I can do $add again. Right? So I can do add 10 and add 10, and I can say, hey, what is the sum of that? It's returning itself, and I can say, hey, what's the sum of that? And now the sum is 24. Right? If you've worked in another language like Python or something like that, you might be familiar with this idea of method chaining. So you can do something like list dot append dot pop dot whatever, right? And you can kind of chain methods together, in dot notation. It's very similar here, except instead of dots, we use a $. Okay, so I wrote, because the method returns itself invisibly, after we call the method add, we have the object itself, and we can call, any kind of function or the method that belongs to the object. We can also access any kind of fields that we have. In this case, we can get the sum out of there. So if we have something like this, for readability, when you chain methods, a lot of times we might say, hey, you should just put these new methods on their own line. So right now, the sum value inside x is 24, and we can call $, and we could put each method on its own line, add 10, ending each line with a $, to kind of indicate that we're chaining another method or another field. And so I can say add 10 again, we get 34. Add 10 again, we'll get 44. Return that sum, and we have, it says, yeah, the sum there is 44. Okay. Let me give you your first view quiz answer, which is the letter B. B as in bear. B is your first view quiz answer. Okay, let's make a slightly more complicated R6 class. And let me also give you, we have this one method called initialize, all right? And this is kind of like a special method name. And when you call initialize, that will override, or I'm sorry, when you define the method initialize, that method will override the default behavior of $new. It allows you to kind of define required fields when creating a new object. You can also kind of perform checks to make sure those inputs are valid. And so I'm just copying an example straight from Hadley Wickham's book, where he creates a new class called person. And this R6 class has two fields. Okay, so we're going to define a person. The person is going to have two fields, a name and an age field. And then we're going to create this method called initialize. So again, class name is capital P person, and we are storing this back into an object called person. The second argument is public, and that is a list, and we put in the methods that we want, or the fields and methods. So we have name comes in null, age, NA, and then we have one method here, initialize. Initialize is a function where we're going to put in a name. The default value for age is going to be NA, and then we're going to say, this is some validation things here. Stop if not, basically, stop if not is going to throw an error if any of these things are not true. So all of these things have to be true, otherwise stop if not is going to be kind of an error. So is.character name, so it checks to make sure name is a character vector, and the length of name has to be 1. So if you give it a character vector of, with more than one value in it, it's going to throw an error. Okay, similarly, age has to be numeric, the length of age has to be 1. And if it passes those checks, then we're going to take name, assign it to $name. We're going to take age, assign it to $age. All right, so we can say Hadley is a person, okay, $new. So we're going to hit the button on the person generating machine, all right, and it asks, hey, what is this? What values do you want to have in this person that the machine's going to spit out? We're going to say, okay, we want you to give it the name Hadley. We also want you to give it the age, and for age we put in a character vector 38, and it says error in here, is numeric age is not true, right? So this is the stop. It says is numeric age. That's not true. Okay, so that there was an error. But here I can say person $new. We want to give it the values Hadley, age is 38, and now we have object Hadley, which is an instance of the person class object. So we have that. We can ask, hey, what is Hadley? And it says Hadley is a person class instance of the person class object. The public field for age is 38. The public field for name is Hadley. We have two methods in there, clone and initialize, and that's what we have, right? This is the default way for the way R6 objects are printed. It just kind of lists off the different fields, and we might say, you know what, I don't really like this, and we can customize this. We can customize the way this gets printed out by defining a print method inside the R6 class object. So here I'm going to expand the way my R6 class object is defined. So inside public, the list, I'm going to add a second method. I still have the fields name and age. I have the method initialize. I'm going to add another method. This method is going to be print. Okay, and again, this is kind of a special method name, so that, and this is going to control the way R6 objects get printed out. So this print function is going to just cat stuff to the screen. We're going to say, hey, what we're printing out is a new person. Okay, and then the second line will have space name, and then we'll access $name, and then the next line will be space age, and we're going to access $age. We'll append new line characters, return that object itself invisibly. And so here I can say, all right, let's create a new instance of person. Person is, we're going to call this Hadley2, and we're going to give it the name Hadley, age 38, and we can say Hadley2 is a person, and it uses the method, right? So this is the way objects get printed out now. Okay, so even though we're not calling print explicitly, just in R, whenever you type the name of an object, the thing that R is going to do is it prints it out. And so this is how the objects get printed out now. And so we say, oh, okay, yeah, this looks like the way I like it or something, and we have that. Okay. Now, one thing to keep in mind is that the first Hadley that we had created was created using like the person generating machine version 1.0, right? So we had the old machine and we pushed new, and it produced an object, a person object Hadley. And then later on, we updated what that person generating machine is, right? We created a new thing and we pushed a button over there and it generated a new person Hadley. So the old Hadley that was defined over here, created over here, doesn't suddenly get all the upgrades of the new version. It was created under the old system, and so it still behaves exactly as it used to. Okay, the new one has kind of the new improvements, so it behaves under the new thing. So the fact that kind of Hadley 2 was created with this, that does have the print method, that changes here, but kind of the old objects, even though they all are also called person objects, don't suddenly get the new upgrades, right? It's kind of like, every year car companies release like a new version of their model, right? So you have if you bought a Honda Civic in 2020, the following year in 2021, Honda releases their new, their updated model. And it's not like your old car suddenly gets the updates of the new one, right? It'd be nice if that's how it worked, but it doesn't. Okay, and every year a new model pops up, and your thing does. It's kind of amazing that our software is under the system. Most of our software, it's like you buy it, and then you get free updates anytime they make improvements. They go, hey. And then your thing updates, right? Well, now everything's kind of a subscription thing, so you have to like pay for it to get your updates. But overall, even like video games, you download them or you like buy them, and then they update, right? Before you can even play it the first time, they have to get an update. It used to not be that way, so that's why. Like the speedrunner communities always look for these little like weird hacks that existed in their first version of the games and things. But anyway, it's kind of neat. Okay. So anyway, just keep in mind, there's no relationship between Hadley and Hadley 2. These are just different objects that happened to have the class name person, even though this was created under old machine 1, and this was created kind of old new machine. As you're working in R and develop classes and things like that, if you create multiple instances, if you have different versions of what person is, that can get really confusing. So in general, clear out your environment. I feel like I say this all the time, but I feel like so many problems, if you find yourself confused with what's happening in your thing, try clearing the environment and working through kind of each code chunk, making sure everything is working the way we want to do it, right? There are other ways you can update or change a class definition. So you can use the set method to do this. So for example, here I'm going to create a brand new R6 class, and this R6 class is going to have the name accumulator. And actually, I didn't even give it a list in public. Right now, that's completely empty. But we can say, but you can also set it after the fact. And so you can kind of just create a new field, and you can say set in public, create a field called sum, give it the value 0. Inside public, create a method called add, and it's going to take this value, which is a function, and things like that. So this is basically redefining our accumulator class object with the same field and method names, but here I'm defining them using $set. we can create classes that inherit from other classes, right? So here is another class. We're going to call this the chatty accumulator, accumulator chatty, right? So you have this option like verbose, which appears and things like that. And basically that just means like talk or output things to the screen as you're doing stuff. So in this case, what accumulator chatty is going to do is it inherits from the accumulator class. So the accumulator class, again, just is a thing where that amasses things by starting off with a sum of 0, and every time we call add, it's going to increase to it. And so this is going to inherit from accumulator, and what we're going to do is we're going to update one of the things inside the public list, and we're going to change how the method add works. And the way method add works here is we're going to just cat to the screen. We're going to say adding x. We're just going to output adding x here. And then what we want to do is we want to take the sum of x, add x to it, and store back to self, right? So I could do, self $ sum plus x store back into self $ sum, okay? But really all I want to do is I just want to call the add method that existed in the superclass, right? So accumulator chatty is accumulating from accumulator, so all I really want to do is just use the add method that already exists. I don't have to redefine anything. I just want to use that exact method that already exists, but it comes from the superclass, so we're going to do this. So really it's just the exact same add function, but we just added this one line which just says adding x. So now the accumulator chatty, we've got the accumulator chatty class. We're going to create a new instance of it. We're going to call that x2. I'm going to do x2 $add 10. And when I do that, it cats add 10 to the screen. And I do add 1, and it cats adding 1 to the screen. And I say, hey, what's the sum? And it says now the sum is 11. So does that make sense, how the superclass and inheritance works there? So, okay, so this is kind of the line that I wrote here. I said, basically, if you don't overwrite any class, methods that are not overridden will implement we'll use the implementation that exists in the parent superclass. And here I just kind of detail out exactly what I said about using the add method that exists in the parent class, or we might call that the superclass. Right? And so this thing also, just like the parent class, returns itself invisibly, and so that's why it works. And this is the preferred way. Again, if you're going to kind of reproduce functionality that already exists in the parent class, you should just use that parent class method when possible. Otherwise, again, you're going to be in a situation where it feels like you've copied and pasted code, and you realize if I want to modify something somewhere, then you have to modify it in multiple locations, which can be messy. Have I given you 2 view quiz answers or just one? Just one. Okay, let me give you your second view quiz answer, which is the letter D. D as in dog is your second view quiz answer. D. D as in dog. Okay, when you call class, it lists off what the classes are. And so we say, hey, what is the class of Hadley? It says, oh, this is a person class object, and it inherits from R6. Hadley 2 also is a person class object and an R6. But we just have to remember that this person, the way this person is defined is different from this person, right? And we don't have, it's just kind of like your Honda Civic and your Honda Civic, they're different models, okay? But we don't have a thing that says, oh, this is the 2020 and this is the 2023 Honda Civic or something like that, okay? They're both person class things, even though these have different definitions. And so again, if you're going to change the definition of the class to just kind of keep everything clean and easy, just wipe out your environment. But we haven't done that here, and so we had these two things. It looks like they're the same class, but they're not. Okay. Accumulator, the x2 is an accumulator chatty class, which inherited from accumulator, and that inherits kind of the base methods from R6. So we have that. You can ask, hey, what are the different names inside the object? And so we have all of these things. These are the kind of the names and the fields in there. We have R6 objects have what we call reference semantics. Okay. R normally does copy on modify. So if I do A is a vector with values 1 and 2, and then I say B is we're gonna take A and assign the name B to it, then right now B and A are pointing to the same object, but then we modify and I say, hey, I want to add 1 to take the first value in B, add 10 to it, and store it back into B. When R sees that, it creates a copy. And so A and B are now two separate objects. We say, hey, what is A? A still has the values 1 and 2. What is B? B has the values 11 and 2. Okay. With reference semantics, this is what we have. We have, we push the new button on the accumulator, and out comes our accumulator class object, and we call this thing X, right? And now I'm going to say X gets the name Y. And basically, I'm just putting a little like sticker, right? So this says, hi, my name is X. And then I'm going to put on another sticker that says, hi, my name is Y, right? So this same object has both the names X and Y. And then so I say, hey, add 10 to Y. And we take this object, we add 10 to it, and so now the sum is 10. And I can ask, okay, what is the sum of it? What is the sum value in X? The sum value in X is 10. What's the sum value in Y? It's also 10, because X and Y are the same exact object. Okay, so when you have a reference semantics, when you so normally in R you have something like here's A and B. As soon as you change something and modify something, it creates a copy of it. We don't have a copy. We just have one object. We originally named it X. We put on another sticker and says, hi, my name is Y. This one object has the names X and Y. They're both pointing to the same object. Okay. If you don't like that, if you want this thing to be X and you want actually a copy, something else, okay, then you can do you can clone it, right? So here we're going to hit the new button, okay, and it out pops a brand new accumulator class object, and we're going to give it the name X, and then we take this object and we say, hey, let's clone it, okay, and we clone it and we get Y, right? So cloning, we have a clone method, so we can take this object, we clone it, and so now we have two separate things. This one is X, and this one over here is Y, and we can say add 10 to Y, and we say, okay, what is the sum over here? The sum over here is still 0. What's the sum over here is now 10. And so we can see that X $ sum is 0, Y $ sum is 10. So you have the clone method that takes kind of currently existing objects and creates a duplicate. Okay, so reference semantics can be tricky, and so you want to kind of be careful. So if you look at something like this, here X is a list, Y is a list, and we create a function that calls in X and Y, we know that when we execute this function, the only thing that's going to change is going to be object Z. We know X is not going to be affected and Y is not going to be affected when we just have copy and modify things, okay? However, let's say we have an R6 class object, capital list, okay? Y is a capital list, okay? So now this function F, perhaps it does things that when we execute, perhaps it modifies something inside of X. Perhaps it also modifies something inside of Y, and it returns something and we store it to Z, right? What happens inside this function is no longer clear. You have to kind of remember, what does this function do? And so things can get a little bit tricky. And so a piece of advice here is that when you write functions, the function should either return a value and doesn't modify any of the inputs, okay? Or the function does not return a value, but it does modify the inputs. And that way it should help you keep track of what's happening. So you see a function and you say, okay, this function is returning a value, it's not going to modify any of the inputs, okay? Or in this case, the function is going to modify the inputs, but doesn't return a value. So for example, I'm going to hit the new button. We get an accumulator class object. And what this thing is going to do, this function, this is going to call, the function is going to be called add 5 to sum, and we're going to take x, and it's basically just going to take the accumulator class object and call add 5 to it. So if I call add 5 to sum to x, then it modifies x in place. So notice I just call the function. I don't store the output of this to anything. And I can say, hey, what is x $sum? X $sum is 5. Okay? This function is going to be sum times 10. And this one is not going to modify the accumulated class object. It's going to just return the sum field multiplied by 10. So here I can say, hey, what is, we're going to say sum times 10x, store that into y. What is y? Y is going to be the value 50. Did it modify x though? No, x is going to, x $sum is just 5. So these are two different kinds of functions. This one modifies x in place. This one just returns a new value. And you have to, if you want to use it, you have to assign it somewhere. Okay, we're gonna run out of time as I start going through these slides, and we're gonna talk about private fields and active fields. I'll say, as far as the midterm exam goes, I will not quiz you on private or active fields, and then you'll have an upcoming homework assignment that uses R6, and you only need to deal with public fields in that, okay? But I want to just kind of introduce this because the concept of having private fields and active fields is a handy thing. Before we get into it, let me give you your last view quiz answer, which is the letter A. A as in apple. A as in apple. Okay. So I just wrote, this is not needed for the midterm or a homework assignment. Okay. When you do an R6 class, you generally just provide a list of fields that go into public. Okay. You can also create a list of fields that go into something called private. Okay. Private values are available only inside the object, and they cannot be accessed from outside the object. Okay. Don't think private is not the same thing as secret. Okay, it's not like things are suddenly encrypted and you can't figure things out. It just means they cannot be directly accessed. Okay, they cannot be directly accessed from outside. So here, if I create public, this is our person class, and inside public I can put in the name and the age. And what can happen is, okay, we can say Hadley2 $age, that's 38. With a public field, you can do stuff like this. You can do Hadley2 $age, let's change that to 25. Okay, and now Hadley2's age is going to be 25, right? So you can kind of modify these values directly inside a public field. And maybe we don't want that, okay? So what we can do instead is we can create we can put our fields inside private, right? So here, notice inside the person class definition, I have two lists. I have public, which has a list, and I have private, which has a list. Inside public, I'm going to have initialize, and we're going to take name and age, and we're going to assign them not to self $name or self $age. We're going to do private $name and private $age. So we're going to do that. And then when we ask, hey, when you print out the person, I want you to access private $name and private $age. Okay, age and name are going to be stored inside private. So here we can create Hadley3. Okay, what is Hadley3? Hadley3 is going to be name Hadley, age 38. Okay, but if you try to access the value age directly from the object, it's not available because it's a private field. So Hadley $3 age comes back as null. If you try to assign a value to it, like modify it, change it to 25, it says you can't do that. This is a locked environment. Okay. However, the values do exist, and we can access them because in the print method, the print method accesses private $name and private $age. So those values are accessible to the object, and we can see them when we call print. But again, we can't access these things directly. So that's what a private field does. Is that okay? This concept of private? You have something also called active fields. Active fields look kind of like a public field, but they're actually defined by a function. Okay, and so the function, if the value, so in the function you can have an argument, and if that argument value is missing, then the active field is going to act like it's retrieving a value. And if it's not missing, then the active field is going to act like it's modifying a value. So, for example, we can say, we can create a new class. This is going to be the random class, the rando, all right? And it has one field called random. If the value is missing, it's going to generate one random number. If you try to assign something, it's going to give you an error. It says you can't set random. So here we can say random $new x. We can say x $random, and we get 0.4323. So it looks like a field, right? It looks just like it looks like it's a value. But every time we call for this value, what it's actually doing is it's executing a function. So this is, it looks like a field, but really what's happening is that a method, okay, a function is being called, right? Even though I don't have any parentheses here, every time I call this, we're getting a different thing. In practice, the way an active field kind of works is, or we might use it in conjunction with a private field. So we can say, hey, you want to access the value? We can access the value. If you want to set it, we can say, we don't want to do that. So here, I'm going to create name. Within private, I'm going to have two fields, .age and .name. And when I initialize, I'm going to do assign name to .name and age to .age. So these are fields inside private. And then active, within active, I'm going to create two methods. I'm going to create a method called name and a method called age. And what age is going to do is when we try to retrieve it, it's going to retrieve the value from private age. If someone tries to modify it, we're going to say, hey, you can't do that. Okay? If as far as the name goes, we're gonna if someone says, hey, I want to access the value, we're gonna just access the value. We're actually gonna allow somebody to modify name, but there's gonna go through a function that says, hey, let's just make sure that the value that you're trying to assign to name is a character thing. Okay, so let me just kind of demonstrate this, and then I realize I'm going over time. So here's a new person, Hadley, age 38. We can access the value name. Just like it looks like it's a regular field, but it's actually an active field. When we call $name, it's accessing the private name Hadley. Here I can actually modify it, and we can change it to Wickham. If I try to assign something numeric, okay, to name, it returns an error because this is actually a function is being executed, and that function has a check that says, hey, it's got to be 10, right? Over here, we can say, hey, what's the age? And it accesses the value, gives us 38. If I try to modify it to something like this, it returns an error, right? So this is kind of how active fields can be used. You can use them to kind of produce values that look like you're just accessing the value, but really they're being generated by a method, by a function there. Okay, thanks for sticking around. We'll go ahead and end here. Have a great rest of your day. We'll see you Friday. Good luck as you study, And yeah, we'll see you then.